action.
So, Joyce, I have them graphing on their graphing calculators, and first of all, they were supposed to find the equation of the tangent line. What did you guys get for the equation of the tangent line of sine? First of all, how do you make it?
Use derivative and plug in 0.
That's part of it.
And then y minus y1.
And what is y1?
0.
Sine of 0, which is going to be 0, that's true, equals, and then what's going to be my m for x minus 0? Because it's going to be sine inverse, nope, sine prime, which is cosine of 0. So y equals x. Boop. Boop. So, plugging in the tangent line and plugging in sine of x in order to graph it, we talked about yesterday real quick at the very, very end. It's a fairly good approximation for a little while. But if you guys zoom in, zoom in, zoom in, zoom in your graph, does it actually meet everywhere there and everywhere there? No. Not perfectly. And how do we know it's not perfectly? Well, what were you guys testing? What were you using the tangent line to approximate?
Sine of 0.2.
So we can use the tangent line, y equals 0.2, to approximate sine of 0.2. Now, without plugging into the calculators, you guys were able to say that this is what kind of estimation? Overestimation, and the reason it's an overestimation or an over-approximation is because?
The concavity is sine. It's concave down.
So we know that's not exact, but who actually plugged in sine of 0.2 to see how close we were?
I did.
No, I mean, like, what is sine of 0.2?
Oh. 0.19866.
So it is pretty close. It is pretty stinking close, but it's not exactly on. And that's a bummer, because it's a good approximation at 0, and things like 0.000000, etc. Pretty good approximation, but this is only, what, 2/10 off, and it's already well, I guess you have to keep on going to different decimals and have to round it eventually to answer that question. But it's already getting pretty far off. So, how can we get a better approximation? We started to see it yesterday, and I was like, look, the pictures get cool, but my question to you guys was, how do you get them to be better? What's the first picture, though, guys?
The one we just did.
Yeah.
What's the second picture?
X cubed.
A cubic? What's the next picture?
Quartic.
Huh. So we have some sort of cubic.
The next one looks like a
Not a quartic. Quartic would be going the same way. These are opposite way. This must be a quintic. So we have a third degree, we have a fifth degree. This one is a first degree. This one is a linear. Wait a minute, where are the parabolas? Where are the
it's
fourth
only
degrees?
odd.
Ooh, they're odd instead of even. And then what would the next one be?
septic. Like a septic tank.
Something like that. Okay, hold on, come back. But where do we get those from?
Our series.
Wait, how on earth did they get this guy?
Taylor series.
Now, just looking at this one, is this series, this power series, is it centered at, or this technically Taylor polynomial? Because it's not a series since it's not continuing. Does that make sense? It's not infinite. Is it centered at 0 or centered somewhere else? Centered at 0 because there's no x minus a, right, in any of those expressions. But how on earth did they get x to the first, x cubed, x to the fifth, x to the seventh? That's not possible, is it?
Well.
But it's supposed to be a prime,
Let me double
maybe
it.
it's smaller.
So how does the Taylor polynomial work? That's ultimately your question, right? The Taylor polynomial says the following. Centered at C, or what are the ones centered at 0 specially called? Maclaurin. And I don't think we wrote this one yesterday, but Maclaurin is going to be the ones that are centered at 0. So technically what we're looking at is a Maclaurin, which is a special, look, a special type of Taylor polynomial, right? Does that make sense? So Taylor is the more general, Maclaurin is a specific, kind of like MVT and Rolls. Anyway, how does the formula work though? C is 0. Well, hold on. Okay, so to make the Taylor, let's try to make it ourselves from sine of x. Using the formula. The formula says, in order to make a Taylor polynomial for a function, it's going to equal, centered at 0, f of 0, plus, what's the next term?
F prime of 0
Times?
x minus c.
Yep, but c is 0. You can think about just all the c's are zeros. What's the next term?
F double prime is 0.
Over 2 factorial, which is just 2.
Couldn't we technically then, just to see the pattern a little bit better, couldn't we think of this as f of 0 all over 0 factorial? And f prime of 1, no, f prime of 0 all over 1 factorial times x to the 1, right? What is 0 factorial defined to be? 1. What's 1 factorial defined to be? 1. This would be f cubed, sorry, the third derivative of f of 0 all over 3 factorial. Okay, so if we're trying to apply this for the function sine of x, right? We could say sine of x is, what am I going to say, approximate or equal to? The nth degree Taylor polynomial is equal to. However, if I'm going to show a finite number of terms, I would need to put an approximate, because if I cut it off somewhere, it's going to be approximate. What are we going to do? We're going to end with a dot, 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 or we're going to end with a certain number of terms?
You can go to the nth term, I guess. Right?
Yeah, but if we stop at the nth term, I still have to say approximate, because that shows a finite ending.
So plus dot dot dots infinite
Okay.
series?
Then we'll say equals. Alright, so then f of 0, well, our function is f, so couldn't I say sine of 0? What's sine of 0?
2.
Sine of 0 is 0. What's f prime? Well, derivative of sine is cosine, right? So we might need to think about a few derivatives of sine first. So we have, oh my goodness, my stylus is not being happy today. Okay. Cosine f double prime is going to equal negative sine. F triple prime is going to equal negative cosine. Now we're ready to go. So 0 plus, what's cosine of 0?
1.
1, and 1 over 1 times x to the 1 is x. Plus, what's the second derivative of sine?
Negative sine.
What's negative sine of 0?
0.
Plus, oh, that's why it's every other. F triple prime is negative cosine. Negative cosine of 0 is negative 1. All over 3 factorial. 3 times 2 times 1 is
6.
6. And then I have x cubed. If 6 is just 3 factorial and nothing simplifies, let's just leave it in factorial notation. The next one would be 0 because it would be a sign again. The next one would be a positive cosine because the signs are going to alternate. And now I'll have, you guys follow the pattern, 1 over 5 factorial times x to the 5th. What would be the next term?
0.
And the next term,
Negative 1.
the signs are going to alternate.
7.
And then technically, because you guys said equals, we're going to go ahead and do a plus and a dot, 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 which is going to end up saying sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc.
Why are the even ones 0?
Because every even derivative of sine will come back to sine, and sine of 0 is 0.
Oh.
Does that make sense to you?
Hey, Miss Steve, maybe that formula I came up with over summer will finally be useful.
For the following? Maybe. I mean, we're simplifying factorials possibly if we're taking derivatives. Is that what you're thinking?
Yeah.
Maybe. Maybe. So then when you guys were thinking of how to get closer and closer and closer, the first one is just going to be y equals x, right? The second one is going to be y equals x minus x cubed over 3 factorial. The third is going to be y equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And each of these are approximations for sign. And what you guys noticed yesterday is not only are they getting to be better and better approximations, but they're getting to be better and better approximations for, finish that statement, for longer and longer intervals. Does that make sense? For longer and longer intervals. Guess what? Sign. Being x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. I think that's something we should memorize, and we will. But first of all, let's go ahead and write down about a Maclaurin. Because if you see Maclaurin, I want you to know what Maclaurin means. It means gangster. So for the nth degree Taylor polynomial, now if you guys notice, are these infinite or are they finite? How they were written? There's no plus dot 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 at the very end. Does that make sense? So this is an nth degree Taylor polynomial because it is being cut off at a particular degree. Something important for you to note. What does n refer to? How many terms or what degree? How many terms or what degree?
Oh, yeah.
What most people would say is how many terms. But the problem is, if I was to, now just to kind of write the notation, to kind of connect the notation to what we just saw with sine of x. If I was to ask you to write, let me just do a page below to make it all nice and clear and separate. To ask you the following question, what is the fifth degree you see why this starts to get a little confusing? It makes a difference right now. You know what I mean? Because if I was to ask you for the fifth degree Taylor polynomial for f of x equals sine of x, how would you answer that? 5 terms or only go to x to the 5th power? A big example. So this word gets a little bit confusing because depending on the function that's being expanded. Thank you, sir. Some functions are only going to have every other term, and if they have every other term, you know the difference between whether we were supposed to write the first 5 terms or whether we're just supposed to go x to the 5th degree. Now, every now and then it might get a little bit more tricky, like, hey, what's the Taylor polynomial for sine of x squared? Uh-oh.
I like how you say that right when Karen walks in.
Uh-oh, or the sine of x
Like,
squared.
you went, uh-oh, right when Karen
Oh,
walks
sorry. It wasn't about you, Karen. I promise. Let me change this and let me be. Okay, now I'm changing it to be A. What if I make it B?
It must be a Yeah. I want to do that. That sounds interesting.
Now what?
X squared, x to the 4th, and x to the 6th.
Or x.
Oh, no, wait,
squared,
you'd have to
x
multiply.
the sixth,
Yeah.
X to the 10.
Oops.
x squared minus x to the what? 6. Why does this make it even more confusing?
So now it's not even to the 5th degree.
Now it's not even to the 5th degree. So what if you're going backwards? Careful. Careful, careful.
Right,
let's keep going.
backwards.
Maybe.
So it's the first 5 terms then?
No, not first 5 terms. It's until n equals 5 in the formula.
Oh.
But n equaled 5 in this formula and n equaled 5 in this formula as well. Does that make sense? Okay. So let's come back.
Get real, Steve.
F of cal.
So when we are talking about, because a few of you guys were asking, when we are talking about the nth degree, be careful that you realize that is when we have the nth power and the nth derivative. The nth power and the nth derivative. And the reason why I'm connecting this is because just because you see something like in the last problem, x to the 10th, if they were to give you that power or that Taylor polynomial, technically that Maclaurin polynomial, if they were to give you that Maclaurin polynomial and say, hey, can you look at this term and tell me what the nth derivative must be as a result? What the nth derivative must be as a result, you have to realize even though it says x to the 10, n is really just 5, so the fifth derivative is what you're looking at. And that's where it gets to be confusing on some multiple choice problems that we will see eventually, just not right this second. Okay.
So
See it now.
it's asking us for like a sub top to speaking of.
They would ask something like, what is the value of the fifth derivative of f of c, based on like a power series that you are given, a Taylor polynomial that you're given.
Yeah.
Okay, we got it? One more time, the polynomials, they're finite, they stop. The nth degree means like a fifth degree, a seventh degree, a ninth degree, a first degree. That would be kind of weird. But they are, if it is a finite, they're going to be approximations. Hence, we're going to have to put the little squigglies like we did with, ooh, what's that other thing that we learned where the squigglies are important to show approximation?
Euler's method.
Euler's method in figures. Anyway,
If we made a series out of a Taylor and Maclaurin polynomial,
this one's boring because it's sine. Although it says find an error for your approximation.
Cooper didn't sound.
yes. Are you?
No, might.
They do have extra tickets. Go ask Richmond. Depends if he has time, though.
Richmond hates me.
Richmond says you'll invite ASP.
Hey George, who messed it up for ASB for on HTTV? Like, that didn't.
Who messed it?
I'm like, 'cause someone told me that 2 people didn't show up, and they didn't tell me when they weren't going to show up.
I don't think that's information that I would like to disclose, especially if it's something that was
But there's been
and
people
it's
all
not a big
week
deal that
doing
it's
it.
messed up.
Yeah, it's middle
because
school
either
week,
way,
though.
It's middle school week next year, or next week is senior week.
I'm sorry, I didn't mean to word it like that.
Yeah, Warrior wins every day. Woo.
It's,
Those kids are literally super lit.
Good.
There's so much. Yesterday we played.
The sixth graders? Is that what it is?
Yeah, that's true. Yesterday we played
Oh, but it's
musical
just
chairs.
the seniors. Is it just 6 and
Sometimes-
7?
You see these
I think
kids?
it's just sixth and seventh or just sixth?
It's supposed to be only 6.
And 6th graders like hang out.
that's it.
And I grew up in mine.
George.
But it's a good reminder for the leaders to remember the little guys. And they are
And I loved it
Boy,
when
are
I
they
was
little.
in set because we did it 6th and 7th grade. So in 7th grade, I loved it. It was fun.
Those kids are fun.
I need to see the leaders on campus and like really get to know them. All right, cool kids. The nice thing is, do we even have to worry about the formula once we start to memorize things like sine, for instance? No. So when I say find the Maclaurin polynomial of degree 5, isn't that easy? Because we're just like, hey, we've been doing that. So if you do sine of x is approximately, we have x plus, oops, no, sine alternates.
Let's write this down in our notes. This is an example.
That's the preferred for each of them.
I see.
However, we would write this as p sub 5 of x, the fifth degree polynomial.
But isn't x 0.1? Is that what we're plugging in? Oh, I missed it.
Then we use it, yeah, exactly. We use it to approximate sine of 0.1.
Let's just. Wait for one, calculator. So this would only be on the calculator portion.
Should be. Yeah, it should be on the
You
calculator.
could do it, but you know. Takes a while.
You don't want to?
I mean, it would be a lot more work than just plugging in.
That's true. This isn't really a fun one by hand. There are fun ones by hand, but 0.1 wouldn't be one. So
Fun as
someone
in-
plug and chug it. If you're not already plugging and chugging, where are the factorials found in your calculator?
Math left 4.
Got it. Or you can do 3 times 2 times 1, 5 times 4 times that, but you don't want to. I don't want
No,
you to.
I don't.
When you say fun to do by hand, do you mean fun as in challenging?
By simplifying factorials kind of thing.
So yeah, I think it's more practical to do the 3 times 2.
Is there a factorial shortcut in the alpha y equals menus?
No.
There's not? I thought there was.
There is.
Alpha, like window, and
9. I only have up to 5.
it's
If you hit alpha window, can you scroll down?
You just got to correct the maximum.
0.0998.
I ran out of space. Hold on, let me go below.
Boom.
Okay, 0. Point what?
0.99.
Oh, yeah.
3. Now hold on. How on earth can they be expecting us to find an error for the approximation and determine an interval in which the actual could actually live?
I'm saying a lot of words at one time.
Okay, how could they be asking for the error?
We're really close.
Hold on, we're not supposed to do that yet.
Wait, isn't that how you find the error?
Ah, you're cheating. You're assuming you know, which in this one you can know by plugging in, but in other ones you can't know. So how are we going to find the error for the approximation? Wait, the only time we've done error so far this year is when dealing with what types of series? Alternating series.
Shoot.
It's an alternating series, which
I
means
rebuke you
the
and
actual
rebuke
sum.
I agree with this man.
Whoa, pause. The actual sum has to be, or the error for the sum has to be.
this. Less than or equal to a sub 1 plus 1? Or a sub n plus 1, right?
And what's a sub n plus 1?
Sine of 1.1? Oh.
How do I do that?
Ooh.
Oh, because it's the next term.
It's the next term. Does that make sense?
Oh, wait, I think the 6th.
It'd be the 7th degree.
But not the 6th, my bad. I can make
Does that make sense? Yeah. No, it's super confusing.
And
But it's the
another one
next
is
term that we have because the 0 isn't a part. So then how do we solve?
Do we need the other side too?
Well, we're going to have like the negative positive version, remember, because that's absolute value. It's technically a negative. So we can say the sum is between, we have the negative 0.1 to the 7th all over 7 factorial plus p sub 5. Here, I'm going to still, this is a.
Nice.
Plus a. And then positive 0.1 to the 7th all over 7 factorial plus a. Is it less than or less than an equal or an equal to?
I think it's equal to.
I think it's equal
What's
to
that
2.
one
I think
we
it's
do?
just the radius of the interval of convergence for geometric is less than.
But I think it's just greater than or less than because you have to do plus 1 at the end to find like the next sum.
Alternating.
Is that one of the
series.
decimal though? You know what I mean?
Where is it?
Alternating series was right before root ratio.
Right,
Would have
right.
been 95.
Oh, here it is. Less than or equal to. Where r sub n is equal to the absolute value of s minus s sub n, which is less than or equal to a sub n plus
Okay, so who's plugged and chugged? What's the decimal on the left?
Oh.
Ah, you guys are killing me. Where are your graphing calculators?
1. Right here. I got it. It's D.
Okay.
Is it
Whichever
negative?
one you're doing.
Yeah, I'll do the positive man.
Okay.
Sorry, I'm going back a little bit on the absolute value of -1, a -0.1 to the 7. Is the 0.1 on is like, you know?
Because it's x to the 7th over 7 factorial, and we're plugging in 0.1 because that's our
No.
specific value.
Like,
I got mine.
oh, it doesn't matter. It's negative anyways. I was wondering if the negative was outside
Yeah.
parentheses.
This D, the numbers, it's too small. Like I think it's 0.17 or 0.1 to the 7 over 7 factorial.
0.17?
The 0.1 to the 7 over 7 factorial is too small to change our number. Because we're getting the same number as it.
Exactly, that's the cool thing. Which means that in order to find the actual sum,
So did we get any error?
well, hold on. Tell me how many digits you have.
All points. You want all the numbers?
Yeah.
You want how many digits I have?
I have 833. Then what? 4167. So kiddos, it's so close that you can't even see a difference in that many
We're
decimals.
perfect.
Isn't that crazy?
It's
That's
not
the
just
cool,
everything
huh?
better.
And we can compare it to the actual, but as we can see, we can basically tell the actual.
Well,
See if when you plug in, do you see any difference?
yes. Last number is 6. So it's
The last number is a 6 instead of a 7.
very negligible.
Pretty snazzy, huh?
Right.
And we only did, this was only what degree of a Taylor polynomial?
Fifth.
5th degree of a Taylor polynomial. Oh man, it's converging, right? Okay, let's keep going. Alright, let's change it up. We've done sine for a while. Let's do ln. Woo! As a 6th degree, if it's centered at c equals 1, is that a Taylor or a Maclaurin?
Taylor or McLaren? If it's centered at, well, McLaren is centered at 0.
How can you remember that? There's nothing wrong with accents. There you go. It works. George is laughing at me.
George, why are you laughing at the teacher?
Oh, so bad.
Think of another way to remember why
That
McLaurin
was
should be
good
centered at
though.
0.
That
Does anybody else even hear my way of remembering?
I did, but I was confused.
What was it?
I said there's George got it. I said there's nothing wrong with accents. Nothing, 0.
Yeah, I get it.
McLaurin. There you go. I don't know why George is laughing.
I get it, but it's not.
was so bad. That was like a
I mean,
Layla joke.
It's late, but like you're
That was a
gonna
Layla
I'm
joke.
gonna remember. Tell Layla I did a shout out to her today.
Oh my god.
I'm nice.
That was a joke.
Come on, it's a way of remembering. It wasn't even a joke.
Is it technically a mnemonic device? What?
Well, I don't know if it'd actually be a mnemonic device, would it?
Oh, I heard demonic.
Yeah, I heard mine too, and I was like, what did George say to you?
I'm so sorry today, Joyce.
We're
I'm
all
not.
over the place.
She must be dying to laugh.
Alright, I'm gonna try to beat
Look
you
at
guys. You're
numbers
taking
and get
forever.
very close
Whoa.
to other numbers. So I'm excited. So I'm not gonna apologize for being excited about being a nerd.
I'm so excited.
No, I'm not excited.
Okay, so Misty, they would never ask for P6 of X for sine, right? They would only ever do
Right.
If you gave us even, I guess it would be like an equal answer, right? And just put like 0.
Why am I finding so many derivatives? And why should you be finding so many derivatives?
And all the way to 6.
It's quite-
Oh, oh,
I'm,
oh.
Anyways, can we just like, there's gotta be another way. There's gotta be some type of formula in this D.
Wow.
George, you can't start asking that yet.
Oh.
You're supposed to see that after. Okay.
Well, I mean, I like the easy way. That's not easy. That's just your word.
F of 0. Wait, just kidding. I'm not doing F of 0. What am I doing?
F, 1. F of 10.
Is anybody thinking there might be a pattern that might start happening?
Okay.
I'm hoping to.
That's usually how things work.
So maybe we're just going to go ahead and say dot, 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 and we'll get there?
Yeah.
Okay. So then, when we plug in f of 1, f of, are we plugging into ln?
Is it x minus 1 or x minus 6?
X minus 1, because that's where I'm centered at.
Oh,
Remember for the
yeah.
for the
I-
Taylor?
I thought that the C was 6.
Oh, got it. What's f of 1? Well, ln of 1 is
0.
0.
That's
What's
it.
f prime of 1?
1/2.
Whoop.
Never mind. Yeah, right.
Plug in 1.
Oh, 1.
1 times x minus 1
X minus 1.
plus, what's f double prime of 1?
1. Whoa.
Negative 1, right? So I have negative 1
Your
over
it's telescopic.
2 factorial.
I think.
7.5 plus, what's f triple prime of 1?
We could pull out x minus 1.
What's f to the 4th, or the 4th degree of f? 4th derivative of f. Bleh.
I'm gonna guess negative 3 over 4 factorial.
Not quite.
The pattern doesn't work.
Not that pattern. Negative 6 over 4 factorial. X minus 1 to the 4th. Aw, stink. Well, where's our pattern? Is it not there?
Is it plus 3? No.
Plus, what would the next one be? 24 over 5 factorial.
Oh, it's times 1 times 2 times 3 times 4.
What did Amanda just figure out?
The pattern.
What was the pattern Ada just said?
And
1 times 2
Times
times
plus
3
1?
times something.
is it like n times?
Because the 2 comes down to join the 1, and 3 comes down to join the 2, and then the 4 comes down to join, and then the 5 comes down to join. Wait, aren't those coefficients kind of like factorials also?
Oh,
The next one would be plus negative 120 over 6 factorial. X minus 1 to the 6th.
So you're
That's not going to be an answer on the AP. Why?
because Satan likes the atheist. He wants a specific.
What's 2 factorial, guys? 2. What's 3 factorial?
6.
6. 2 over 6 is 1 over 3. What's 4 factorial? What's 6 times 4?
24.
24. What's 6 over 24?
1/4.
What's 5 factorial? What's 5 times 24?
120.
120. What's 24 over 120?
1/5. The pattern. Does life have a pattern, Miss D?
Some patterns that should be repeated and some that aren't.
So wait, so all the answers to life is just in a pattern? I can just copy them?
Nope.
Come on.
But there are some patterns that are going to help
Can I copy them?
if you figure them out. Some you want to copy.
Can I copy them all?
No.
Can I copy
Don't
and
copy
paste them?
all patterns.
All the good ones?
Some, yeah.
Can I download them somewhere?
Nope, you can't start journaling about them as though they're written down.
Yeah, come on, Miss D.
What?
No speaking.
oh ow.
Does that make sense?
Yeah.
Wait, then use it to approximate the value of ln of 1.1.
Oh, wait, hang
Plug
on.
it in, plug it in.
You said what?
Okay, so.
But wait, it gets easy, because it's 0.1.
Wait, how's it get different? Look at number 5.
Ah.
Suppose that g is a function which has continuous derivatives such that there's g prime, there's g double prime, there's g triple prime.
Yeah,
Guess what?
what's up?
They're getting us ready for a Taylor polynomial.
Look this up.
How are we going to do that?
Look this up with the answer.
Yeah.
So it's easy.
We can say p sub 3 since we don't know who everybody is, right?
Yeah.
P sub 3 is equal to, that's a Taylor polynomial that approximates g of x. That approximate, I did it backwards and it looks awful. So how do we use our clues? We just know the formula, right? And the formula says g of
Oh, G? Yeah, G.
plus g prime of 2 times x minus 2. Wait, why am I subtracting?
The to the center.
Good, it's Taylor, not McLaren.
McLaren, not Taylor, or Taylor, not McLaren.
This is so easy, guys. Right?
We're gangsters. Look, I don't think I can make anybody cooler than us except for maybe and Karen. She grades all the cuts.
Right now she's not being entirely.
Wait, don't we still have to divide by the?
Whew, finally! I was waiting for that one. This would be an answer. Why would it be wrong though if you try to choose it? You forgot to divide by. That's why it's dangerous, I think, sometimes to not write it from the get-go. Because then we just start writing and then we forget that we're supposed to add in factorials, right? So be careful, because I can promise you, there's going to be some with and some without. Does that make sense for your multiple choice answers? You guys double check, everything all good? So it's not that you necessarily have to write them every time, but you just can't forget them. Are we good?
Right. You can. Sorry, I just remember that saying from Lilo and Stitch. Something, but never forgotten.
No, it's
That's sad.
no one gets left behind.
Whoa!
Honor means family, and family means no one gets left behind.
Wait a minute. Example 6. What's going on? Use a third degree Taylor approximation?
Taylor.
Oh, good job, Cornelius. It's good. Good.
Welcome, Joyce. Those are life lessons.
Oh yeah.
Don't learn anywhere else.
Write it down.
Copy and paste.
What's a third degree Taylor polynomial? V to the x. I don't know.
Exactly. That's my answer.
Wait a minute. Hold on. If I was to start taking derivatives, because of course we're supposed to, right? To make it Taylor. Wait, how nice is that? Do I need to actually worry about multiple derivatives?
But what's the limit?
Oh, we'll see. So the third degree Taylor approximation is going to be, near 0. So where are we centering it at? Where are we centering it at?
We have to go like close to it.
I started writing tutorials, but I guess I don't really need them as long as you don't forget.
Miss D, do you remember when I was in pre-cal and we were learning?
Wait, hold on. You're writing, right?
I am writing.
Okay.
We were learning limits.
I mean, specifically, no, but I remember that we did it. So
Yeah, well, I came across this exact limit on homework, and I couldn't figure it out.
What's e to the 0?
Quan.
This exact limit. That's crazy.
And he told me look at tiles, and I was just like, what?
1/2 x. 1/6 x.
Just to make it look nicer, couldn't I do? Hey, look, he has a nice pattern too. I bet he's a special one we're going to have to memorize. Wait a minute. Use a third degree Taylor approximation of e to the x for x near 0. Hold on, what is p sub 3 of 0? Right, so we plug in 0, 0, 0, 0, 0, 0, 0.
Oh, yes.
What?
Why are they having us do that?
Shows that e adds.
Compared to the actual limit at 0, why are they asking us to use this? You can use the approximation to plug it in, then compare it to the actual limit.
-1/2. Wait. Stop when.
Why do they say use it near in order to plug in?
You gotta go plus a little.
E to the 0 is 1, 1 minus 1 is 0, 0 over 0. What happens? We have to plug it in, but we could technically, instead of plugging in like 0.1 to e, we could plug in 0.1 to the power, the Taylor polynomial, and be able to approximate without maybe the methods that we use with one. Anyway, girls, we're continuing this tomorrow, just a little bit. This homework isn't due until Monday, but I'm hoping to finish 10-2, start 10-3 tomorrow, just to give you a heads up. Bye, Joyce. Talk to you later.